Greg, so great to have you on the podcast. How are you today?
I'm great, Jared. Thanks for having me.
Let's dive right in. We tend to keep these short and sweet for the audience. And first, love if you could tell the audience a little bit about yourself, and then give us an overview of. I hope I'm saying this right. Is it Geminus?
Geminus, yeah.
Geminus. Okay.
Right.
Actually, really, Geminus. Okay, it rolls off the tongue nicely. And that's Geminus for those of you listening in. That want to check it out. But yeah, first tell us a little bit about yourself and Geminus, and then we'll dive into a cool conversation.
Again, thanks for having me. Yeah, so Geminus, and it really, let me tell you a little bit about my own journey, and then I think we can talk about Geminus because the two are closely connected, as you can imagine. I'm a mechanical engineer by training. I left my PhD program in mechanical engineering in 1995 to join a startup at the time, and what we were doing was helping industrial companies simulate their products, whether they be airplanes or power plants, to simulate their products in copious detail. As maybe your listeners can remember, in the 90s, the price of compute power was coming way down. So that surplus compute power made it possible to start to do these really sophisticated simulations. And they're pretty geeky simulations. We were really solving equations, partial differential equations related to the physics that govern the way that things move and react around us. So that was where I got my start. That company was called Fluent. We got acquired in 2006 by a publicly traded company named Ansys, which is about to be part of Synopsys Corporation. I think they're just finishing up a $35 billion acquisition. So that was a pretty exciting journey for me, and that was really part of a lifelong interest in kind of simulating the physical world. I always imagined what it looked like around me, and so that was kind of pursuing my childhood dream. I stayed really interested in this area of simulations, and started to look at how deep learning was going to impact the way that we were simulating things around us. And my co-founder, Karthik Doraisamy, who's now at the University of Michigan, was doing research in the, say, early to mid-2000s, looking at how you could take deep learning and combine it with these fancy simulations. So that was my journey, Karthik's journey. But fast forward to today, we created Geminus to do one thing, and that was help industrial companies unlock productivity, right? And what do we mean by that? We mean specifically that decisions that engineers make every day look from the outside to be super sophisticated, but getting information to make informed decisions as an engineer, if you're operating like a power plant or an oil refinery, can be really difficult. And even today, most decisions are a big percentage based on experience and knowledge, and which is great. But the question is, how do you encapsulate that knowledge and experience into an AI model so that you can make decisions perhaps more quickly? And so that's what we do. The problem is massive. If you look at industrial companies in general, they sit on top of massive amounts of real data that they've taken in terms of measurements out of their machines. To give you an example, the average oil field generates in 1 month the same amount of data that it took to train ChatGPT 3.0. So you have these industrial companies with just massive amounts of data, used in some cases, but a lot of it remains unused and dormant. In addition to that, you now have a situation where almost every engineer has access to these really powerful simulators, which create synthetic data. And so they're creating synthetic data with surprisingly high accuracy to do their jobs as well. And so you can think about what Geminus does is really bring the two together, the synthetic and the real data, to help these large industrial companies unlock insights, right? And so what does that mean? That's a pretty esoteric idea. So let me give you a real life example. So this is an application that we're working on in Northwestern U.S. with one of the larger oil companies in our country, and they have a network of natural gas wells that are producing natural gas that comes out of the ground. They have a bunch of pipes that transport that gas to a facility that removes the pollutants and gets the gas ready for sale, right? It's a pretty simple concept, but there are hundreds of gas wells, and transporting it through a series of pipes is more complicated than you would imagine because of a number of things. Number one, the wells are changing all the time. So the pressure coming out of the wells are constantly changing, things break. So sometimes you have to reroute the gas. And having a human being try to figure out how to navigate 10,000 control points like valves and pumps is really difficult. And it's not done well. And in this particular case, when it's not done well, it results in flaring methane to the atmosphere, which is both lost sales product and terrible for the environment, right? And the reason why they have to flare methane to the atmosphere from time to time is that the gas, the methane in these pipes, gets pressurized so much by changes in temperature that it could explode. And so you have to vent it to the atmosphere to prevent a safety issue. So what you could do with AI, and what we've done with this particular company, is taken real data together with synthetic data about this pipeline and made an AI model that can, in milliseconds, tell the operator exactly what to do to change or control the gas flow through that pipe to avoid a flaring situation. It's been super successful. So that just went live last week, actually, that particular application, and we're working on scaling that up to other applications. But that's an example, and what that means for the company, right? So not only are we not flaring gas to the atmosphere, but you get a huge bump in the production of natural gas. I think that particular gas field, at this point in history, flares about 5% of the gas that comes out of the ground. It's a huge amount. But you can imagine a 5% bump in your sales if you can stop flaring that gas.
I know it's not just like for oil and gas, you work in other areas as well. Can you, for our audience, can you tell us some of the other areas this is applicable? I know you said it, you gave us kind of the overview of the different types, but like even getting more specific, like who else fits in that bucket that you can end up working with?
Yeah, for sure. Another problem that we're starting to work on today is the electrical grid, particularly electricity as it flows around data centers. It turns out that getting electricity to flow from the source that's creating the electricity to the source that consumes it is a very dynamic and complicated process, not unlike the natural gas process. And so if you can use AI models to accelerate and improve the decision making, you can ensure the reliability of those data centers, and you can also make it easier for the companies creating the data centers to scale, to better understand how they're going to affect the public electric grid, understand what the risks are for generating different types of electricity. So that's another example. Other examples that we've worked on include, let me think here, things that I can talk about. We work in the defense area quite a bit. So in that particular arena, you can imagine satellite tracking, right? So we've got all these satellites above us doing really incredible things. Every time you want to take a picture of somewhere on Earth with a satellite, you have to often move that satellite. And moving that satellite affects everything else in space. And there are thousands, almost tens of thousands of things floating around at any given place in the atmosphere. So having an AI model that can very quickly go through those calculations and understand if I move my satellite over 15 degrees, is it going to bump into anything, is a real world problem. So that would be another one. Looking at natural gas power plants, how do you reduce your carbon dioxide emissions by more efficiently burning natural gas? It would be another one. So there's anywhere that there is physics involved, there's really an opportunity for us to help out in usually one way or another.
One of the things that's so interesting too about what you're doing is these simulations. This is not like, if Johnny drops his ice cream cone, like what are you're at a total different stakes like situation, right? Lots of money is involved, safety is involved. If these simulations, if they don't have the insights that you're providing as a result, it can sometimes not be great. So they need this information. Um, Obviously, AI and how it's just continuing to progress has been huge for your business. AI has often been called kind of the next industrial revolution, right? Would love your take on just the state of of AI in general, like right now, also in how you continue to see it impacting your business over time.
Yeah, for sure. I think we're at the very beginning of a long journey with artificial intelligence. I can talk about our world a little bit better than others. In the industrial world, we're just getting going. There aren't many companies doing what we're doing in the industrial space. There's lots of internal projects going on at most large industrial players, but those are mostly research projects. So I would say, especially in our space, we're very, very early. But if you look around and just think about how in 1 year we've started to talk about AI because of the prevalence of these new LLMs and the different use cases that we've discovered in 1 year, we're just scratching the surface. I think if you think about the evolution of computers, I think that's a good analogy. We're just compressing it into a much shorter time period, right? I mean, you had these, Texas Instrument computers first appear on the marketplace, and that evolved slowly, but it changed everything. And I think AI will change everything, but it's going to happen at a much faster pace.
One of my biggest frustrations is how I just constantly hear from people, we're 6 months from, and then 6 months happen. Now, we're always closer 6 months from that point to, whatever that person was talking about in relation to AI progressing. But how do we still plan for the future in all these businesses, but also avoid the trap of we're 6 months away that I keep hearing over and over and over again?
Yeah, so Jared, that's a trap that makes me nervous. And I think that the way that we get around it at Geminus is really simple, right? I mean, instead of worrying about like what the big future looks like, let's just worry about driving value that we can today, right? So when we go in to work with a customer, the first question is, what can we do to drive value within the next 3 weeks, right? And so we know that if we can drive real tangible impact on our customer's business in 3 weeks, that's massive. And then the next question is, how do we expand that business, the impact that we're driving? And then we just keep taking one step after another. What I worry about when somebody says, it's just 6 months away, we're often taking a really big bite, probably larger than we can chew. And I think the way to get around that is to take smaller steps and just try to show value each step of the way. Because the reality is we don't always know where we're going, right? So everybody's kind of finding their way in the dark. And when you're walking through a dark room, you don't take giant steps and run through the room. You move slowly and kind of take one step at a time.
I think it's just human nature too to take those more giant bites, thinking something is going to be further along than it actually is. What's that phrase? I'm going to butcher it, so I'm going to hope you know it instead. Something around like you overestimate what you can do. What you know that phrase?
Oh man. Well, this is where I need to bring up ChatGPT, but yeah.
I know. This is this is exactly, if we weren't doing this right, that's what I would do. Anyway, but like something around the lines like you overestimate what you can do in a year and underestimate what you can do in like a decade or something like that. I think that thinking needs to come into play, and it's probably the opposite or one or the other. Anyway.
Yeah. No, everything takes 10 times longer than you expect. Is the general phrase, and so I think we do have to be really realistic about what we can accomplish in the near term. But to your point, I don't think that we should limit ourselves in our thinking in the mid to long term, right? Because the impacts, I think, over the next 10 years are going to be absolutely massive. And it's fun to think about what those could be. And you almost have to, because it would be irresponsible not to, but your chances of being wrong are pretty high.
One of my favorite exercises to do is to go to ChatGPT for pretty much every industry and just say the year is 2050. What could this space look like and why? And it's so interesting to kind of see, like, it's almost like we used to go look at movies and TV shows, right? Like the Jetsons and Back to the Future, to see what the future could look like. If I always said if they're writing about it in movies, it's very likely we're going to be seeing it real soon, right? But it's been a fun exercise to do that for certain things. Also to see what it's missed, right? Like there's some clear, gaps across the board. Like I'm sure if you did it for your industry, you would look at it and it would miss a ton of where you actually see the industry going. I would like to hear a little bit as we kind of not wrap up, but like tell me where Geminus is going from here. Like what really excites you? I know there's a lot that excites you, and there's only certain things that you can share, but what excites you about what's next?
God, so I get excited because we're seeing so much value in kind of the near term of what we're doing, and we're working on what I would be consider to be really big problems like that gas problem that I talked about. But that's just one of like 1,000 assets at that particular company, and so where we're going is once we solve kind of one of these problems, you start to link them together because gas fields talk to gas processing facilities, which talk to gas pipelines. And so, what I get really excited about is not breaking through in kind of one little decision-making area, but looking at the entire enterprise and the connectivity between all of these different disciplines and models. And so, we've been working on some new technology that'll allow us to kind of couple together all of these different AI models so that you can have an enterprise view of what's going on within your company or enterprise. And that's when you start to look at cross-discipline decisions. So I get super excited about that. And so that's at the enterprise level. We're actually also talking to some customers at the country level. So how do you look at all of your energy assets and how they're operating together and how they could operate together? And so I get excited about the kind of the scale of the problem that we're starting to get into and being able to tackle.
We also do kind of in a separate channel a lot in the energy space now too. So maybe there's something we could bring you back on to really just continue to focus in on that side of the business as well. But Greg, I really appreciate you coming on and sharing some info with us in this quick chat. Definitely stay in touch, keep us updated on any news. But wishing you and the team all the best of luck and keep working on something special.
Yeah, thanks so much, Jared. Great to see you. Have a good one.